Well, it seems to me that I conveyed the idea to you that statistics have to be kept as graphs. Yes. Very well. When I was explaining it, I used the word trend. Speaking of that, let me acquaint you with it. Yet another very important term, which has quite a direct correlation to the chapter on statistics. And this term is known as a trend. Trend means the tendency of statistics to average out up, level, or down over several weeks or even months, as long as the situation remains. L. Ron Hubbard. Alright. Just imagine having this situation. Your company has an information center which contains all the necessary statistics, both sufficient in quantity and significance. And you look at them. What's next? What does one do with all of that? Well, alright, you look at some statistic and it grew. So what do? We become happy. Very well. And if it drops, then what do? We become sad. And is that it? You get happy or sad? Tell me, would you be interested to know that it turns out that there is actually a technology about what you do with a statistic and what exact specific steps you take in case it's behaving this way or that way or like this or going sharply up? Would you be interested? Well, of course. My companion Vadim, I asked him to help me figure out your whole case. And he did a brilliant job as I see it. And this file is for you. It has a collection of unique materials, and they actually describe the exact algorithm of actions in full, the one you have to apply when a statistic is doing this or that. And you will get this file for sure. But before that, I want to introduce to you one more truly important datum. There is a law that holds true in this universe whereby if one does not correctly designate the condition he is in and apply the formula to his activities, or if he assigns and applies the wrong conditions, then the following happens. He will inevitably drop one condition below the condition he is actually in. L. Ron Hubbard. Hence, we have a conclusion, a very important one. All the conditions of existence are located in sequence from lowest to highest, and it's very important to find the right condition. Let's say that you think or you suppose intuitively that you're in the condition of normal operation, but you're actually in emergency. And then your next destinations will be danger and non-existence. And that's a law. This also works in reverse. You could erroneously decide on your condition as you're moving from bottom to top, meaning you could decide that you were in danger and actually you were in a normal condition, in a condition of normal operation. And then your next destination will end up being down from normal operation. So what I want to emphasize here is that it's vital to make a correct estimation of the condition you're in. To be able to make a correct estimation of your condition, you have to have the opportunity of properly scaling the graph. And that is its own technology. How you scale a graph. So, we're talking about the scale on the graph. Now, look, here's a graph we have. What can you tell me about it? What is the trend of this graph? Nothing really. I agree. And what about this graph? Why, here you can see right away that it's rising. I'd like to point out to you that both graphs have the same values. You mean the same numbers? Yes, exactly the same values. And the reason why these graphs look so different is nothing other than the way the graph was scaled. There are rules in scaling a graph. Here they are. Step 1. Determine the lowest amount one expects a particular statistic to go. This is not always 0. Step 2. Determine the highest amount one expects a particular statistic will go in the next 3 months. Step 3. Subtract 1 from 2. Step 4. Proportion the vertical divisions as per 3. L. Ron Hubbard. Alright, let's try and use these 4 steps to work out a correctly scaled graph that applies to your company and its activity. Let's do that. Interesting, isn't it? Alright, let's say this. How many chairs do you expect would be the absolute lowest that your company would make? Really the absolute lowest. You won't go any lower than that for sure. How many? Well, we're not going to go any lower than 50 for sure. Very well. Remember that it says in scaling a graph, this is not always 0, which means that we're going to put down the number 50 on the lower axis of the graph. Yes? Yes. Alright. Now let's do step 2. How many chairs do you expect that your company could produce and sell in the next 3 months? Well, approximately. Well, maybe 150. Yes, it's possible to sell 150 in a week. Good. Now that we've decided on that, we're done with step 2. In step 3 it says, take what we have in step 2, which is 150, subtract it from what we have in step 1, which is 50, and we get 100. 100. Step 4 says, work out the divisions for the vertical axis on the graph, and you will have the right scale. So, we put 150 on top, 50 on the bottom. We work it out, and we get 1 division, meaning some vertical section of the graph's vertical axis is how much? 10. 10 chairs. We can also write on the graph 1 division equals 10 chairs. Do you have the data on the last 6 weeks at your company? Yes. Let's make a graph right away. Let's do it. Vladimir, tell me your numbers. 65, 78, 90, 110, 85, 84. Thank you. So here we have a graph. Can you now determine the tendency or the trend of the direction of this graph is going? Yes, of course. Yes, it's all quite obvious. So I congratulate you then. And if you now have a clear, understandable algorithm of actions regarding this condition, then where are you going to go next when you carry it out? Up. Upwards. There is one more addition that I want to make to this. There is a technology of how you use an upside down graph. What do I mean by this? There are indicators, well, let's say the number of defects or the number of complaints from buyers that you have to show using a technology called upside down graphs, meaning the less the better. And we need this technology of upside down graphs in order for the graph to be visually perceived as rising. In other words, headed up towards 0. That's why we need such technology, so we can see when we're doing good. That's not too hard, is it? To finish off talking about statistics, there is one important point I couldn't forego. Look, which statistic should be rewarded and which should be penalized? You know the answer. The answer to that question is obvious. But does it actually happen like that in life? Unfortunately, quite often what happens is the exact opposite. Well, let's say we have Father here, and he's sitting at home in an armchair and reading a newspaper. His little son is playing nearby, building a house out of blocks with enthusiasm. Father looks at his son and says, "Aha, the kid is busy working. All is well. There is no need to interfere. No need to give him any extra attention." The child has somewhat different ideas. He looks at the father and says, actually he thinks to himself, "Why isn't my father paying any attention to me? I built such a nice house here, etc. My father doesn't care," he thinks. "Let me get some matches and see if I can burn father's desk. Ha! And here father starts paying attention to his son. He's right there." Look, unfortunately the exact same thing happens in business too often. Let us say that an executive is conducting a general staff meeting and all his staff are there. Let's say including Dasha and Vova. And let us suppose that Daria did a really good job last week and she had rising statistics, but Vova, don't be offended now, was a downstat last week. So what will the executive usually do? He says, "Dasha is all fine, but why were you goofing off, Vova? Who or what was in your way of having good indicators?" And Vova says, for example, "Well, I was ready to do it, but my typewriter broke, so, well, I wasn't, sure of how to get the result." And the executive says, "All right, here, take my new typewriter, but make sure and produce what is expected of you next week." And now we have the following situation, Dasha thinks. "Aha, so I tried hard all week long, I pushed my statistic up, but Vova gets a new typewriter. What does she need to do to get the same thing?" Exactly. She needs to crash her statistics. And Vova is thinking this way, "Aha, interesting. I was goofing off last week and I got a typewriter. Alright, let's keep it up in the same fashion." The executive's actions have to be the exact opposite. He would ignore the downstat, sort of, sure. He has to deal with him later and separately in his office, but publicly he would acknowledge the person who created a good result. And he says, "Dasha, it's an honor to me that you're working at our company. These flowers and this bonus are for you, and all the rest." So, we have a key conclusion here. When you reward down statistics and penalize up statistics, you get down statistics. L. Ron Hubbard. Alright, my dear friends, that is that. We could say that the KPI, Key Performance Indicators case, is complete. I want to give you this file. It contains all the materials on your case. It contains both what we talked about today and the materials that my colleague, my companion, Vadim, prepared for you. It is with pleasure that I hand it over to you. Use it, and I wish you rising statistics.